Hi there, and welcome to our project demo for our Computer Science 334 project. Simon handled the front end of our project as well as the login page. John and myself handled the data cleaning. Petroné handled the employee queries. Jaco and Hans handled the graph visualization. We used a combination of MySQLite, MySQL, and Neo4j to implement the various aspects of this program. Simon will be giving you a run-through of the functionality of the login page, and then Hans and myself will give you a run-through of the functionality of both our user queries and the graph visualization. Enjoy!
Okay, so here you can see we're at the home page of our website. So to view any of the things that this website actually does, we first need to log in. So we'll go to the login page here in the nav bar. Now we don't have a user that we can log in with yet, so we first have to register a user. So we can click on register here, and let's have this user use example@gmail.com for their email, and let's first test that the passwords need to be equal. So we'll make 123 and 124. So the passwords have to be equal and they have to be at least 12 characters. So let's use a password that is 12 characters but that does not contain an uppercase letter to test that part. You will see that the password must contain at least one uppercase letter. We can do the same for the lowercase letters, so type the password in all caps. We'll see we need at least one lowercase letter, and then we can test the same functionality for special characters, because the password does require at least one special character. So let's try that. And we'll see the password requires at least one special character. So now let's actually use a valid password that contains all of these attributes. And you'll see that our user has successfully been created. Now what we can do to test that duplicate users can't be created, we can go and register another user with the email address example@gmail.com and a valid password. And you'll see that it says the username is already in use. Okay, so now let's test our login authentication with Java Web Tokens. So we can log in. And you'll see that our user has successfully been logged in. And this is a route that can only be viewed when you are logged in. So as you can see, it says over here, this is a protected view, and this view, if you try and view it without logging in, it will redirect you to the login page, which I'll show shortly. But first I'll show how the Java Web Tokens work. So whenever we try and view a protected route such as query, then the Java Web Tokens, which are stored in cookies on the browser, will be sent to the server. So here when we go to query, the Java Web Tokens are sent to authenticate this user, and these Java Web Tokens don't expire. So if we were to close this tab and we go back to the website, you can see that we're still logged in because these cookies are stored on the browser, the client's browser, and they'll only be cleared if the user clears his own cache. So now what we'll do is we'll test the redirecting of protected routes if you try to view a protected route but you're not logged in. So let's go to query, and we see that the route is a /query. So now we log out, and what we'll do is we will try to access the query page, and this should not work. As you can see, we have to log in to view this page, so because we couldn't send the valid Java authentication token, we were redirected to this page. And if we log in with valid credentials, we should be redirected to the query page. As you can see here, we are on the query page, so everything works, and that is the login system.
We will start off by having a look at the social network visualization. This graph is a visual representation of how Enron employees are connected to each other through the emails that they sent and received. This is a responsive visualization which allows you to toggle nodes to get a better view of the edges connecting employees. Next, we will have a look at our shortest path visualization. Our web app allows you to enter the names of 2 Enron employees and will display the shortest path between these employees. In this case, we can see that Philip and Matthew did not communicate directly with one another, but they did both send emails to the same employee. This is our clustering visualization where different colors indicate the different communities or groups that were identified by the algorithm, and nodes represent individuals. The last visualization is the centrality algorithm, where the darkness and size of a node indicates importance, so prominent Enron employees have larger, darker nodes. Now we'll move on to the functionality of our employee queries. In this example, we can see that Philip Allen sent a total of 446 emails, and we can see the 5 employees that he contacted most frequently. Again, we can have a look at the employee queries for Eric Bass. Since the 1st of January 1999, he sent a total of 1,516 emails, and we can also see who he contacted most often. Our web app will also notify users of invalid employee queries. So if a user does not enter a start date, they will be prompted to do so. One should note that if no end date is specified, a default end date of today's date will be used. Here you can see the pop-up blocker prompting an employee to enter a valid start date. And now with the valid start date, the results are displayed. Lastly, note that not using an employee's surname will return results for all employees who share the same first name. So here if we enter Matthew, we can see that there were 2 employees with the first name Matthew at Enron, and results for both of these employees are displayed. And that concludes our project demo. Thank you for watching.